Welcome to QNon7.com. Please like, share and subscribe my video. Today we're going to look at the metallic bonding. We have looked at the covalent ionic bonding. This is the third type of the bonding. Metallic bonding, with the name you can clearly state that it has got something to do with metals. Metals are actually ductile and they actually you can bend them into shape. It's because they have got the ions which are actually can slide on each other, and that's why they are malleable as well. Metal ions, so the definition will be the metal ions are held together by delocalized electrons. So it's a bond between the metal ions and the electrons which are delocalized, and I'm going to explain that in a minute in detail. For example, if you have a sodium metal which belongs to the group 1, it has 1 electron in the outer shell. The maximum it can have 8 electrons in the third shell. So it's better for the metal to lose that electron and become stable by having the second shell completed. For example, it has an atomic number of 11. So 2, 8, 1 is the electronic configuration. Out of 11, 2 in the first shell, 8 in the second shell, and 1 in the third shell. Maximum you can put 8 electrons in the third shell. Now, an atom is stable when it has a complete outer shell. So in this case, if you want to gain 7 electrons, it requires huge amount of energy. So that is actually something impossible. So atom on its own cannot do that job. So atom will prefer to lose this electron and become a positive ion. Any atom which loses electron called a positive ion. So sodium will lose an electron, become a sodium ion. Now all of the sodium ions, this is how they look like. They will lose that electron and they will have their outer electrons which can freely move. They're not gonna go away somewhere. They do not lose to something else, but it will stay on the top of the surface. So the negative charge, because electron has a negative charge and metal ions has positive charge, so they will have a strong electrostatic force between them, which is keeping them together. Now you need to understand what will happen if you have, for example, if you have this, for example, this is sodium. What if you have magnesium? Magnesium belongs to the second column of the periodic table. Its atomic number is 12, so 2, 8 and 2 means it has 2 electrons in the outer shell. It will still lose those 2 electrons to make a positive ion. All the metals, they make positive ion anyway. Now metal ions will stay the same, but this time each of the metal ion will lose 2 electrons. So you can see that the number of proton and number of electrons are increasing because of atomic number. And for 6 electrons, I'm just giving an example. For 6 electrons, you have 12 electrons outside to hold them together. Sodium, 6 atoms will have 6 electrons to hold them. And obviously magnesium has got 6 atoms held by 12 electrons. So you have 6 atoms, but you have 12 electrons because they have 2 electrons in the outer shell for each atom. Here you have 6 atoms again. I'm just giving an example, and you have 6 electrons. Now you can see that the amount of electrons is getting higher. The more electrons and more nucleus charge you have, the more stronger the metallic bonding is. So that's why when you actually increase the atomic number or when you increase the outer electrons in the metal, they will actually have a strong metallic bonding. Okay, so across a period, metallic bonding increases. As you go down the group, the metallic bonding strength it decreases. Now, because generally I'm going to talk about metals have a high melting point and boiling point. And the reason they have, why they have a high melting point and boiling point, because they are actually have a strong electrostatic force of attraction. So the examiner is asking you why they have a high melting point and boiling point. You can say they have strong electrostatic force of attraction between metal ion and delocalized electron. Can I quickly explain this delocalization? You probably use Snapchat and WhatsApp and all of these apps. If you switch off your location, people cannot locate you. But if your location is on, they can locate your position the way you are. So when you switch off your location, you are delocalized. That nobody can actually find your exact place. Now, when you talk about these electrons, the electrons are constantly moving on the surface of the metal atoms, and you do not know whether this electron belongs to this metal ion or this metal ion. That's why we call them as a delocalized electron. We can call them as freely moved electrons, which is still okay. You will still get the mark, but delocalized electron is the right word. Now, because they can constantly move on the surface, normally in ionic bonding or in the covalent bonds, they do not conduct electricity when they are in the solids. Covalent bonds are a poor conductor in the liquid as well anyway. But in solid, they do not conduct any electricity at all because they do not have freely moved charges or electrons. In metals, even if it is a solid, you say copper wire, all of them, iron, they can conduct electricity. And the reason is they have a freely moving delocalized electron. So one is high melting point, boiling point because of the strong electrostatic force of attraction. And the second property is they have free moving delocalized electrons. So they are good conductor of electricity and heat. So that's how the metallic bonding works. Thank you very much. Please wait for the next video about the giant covalent bonding.